Okay, so what we have right now is we're looking at what we did yesterday after the quiz with the mean absolute deviation. So just to kind of review over what the activity was about, here's 10 home run lists from 2023 of Major League Baseball players. These are the top 10 home run hitters. Okay, so these are how many home runs they hit in 2023. So remember, on Desmos, first thing you're going to do is you're going to put in your list. So pick a letter, set it equal, put the bracket, make sure it's a square bracket, not the brace, and you just start typing in the numbers. So make sure the only commas in the problem are the ones separating the numbers in your list. Okay, so we have 10 elements in our list. Now, to do the mean absolute deviation, remember this is, you find the mean, and then you find the distance from the mean to each of the values in your list, and then you take the average of that. So what we're going to do is I'm just going to show you the mean here. So the mean of A is 42.5. That means the average number of hits is 42.5. Then you were given a long equation, but your Desmos has a shortcut. It's the MAD, the mean absolute deviation. And again, you just put your letter in there, and your mean absolute deviation is 4.2. So that tells you that there's 4.2 spread of the average distance from the mean. Okay, so the average distance of each point from the mean average is 4.2 hits. Okay, now on your assignment yesterday, you also had to create some box plots. So I want to make sure you remember how to do that on Desmos. So remember, you just type in the word box plot, and again, put your letter. Now, if you'll notice, it doesn't show up on the grid. So remember, that's where the zoom fit comes in, that little magnifying glass, and now you can see the box plot for our numbers. You could also do this with a dot plot. Okay, so again, you can turn the box plot off if you just want to see the dots. Okay, you can kind of see where everything is, the median's in between those two numbers. Okay, now you can also do this with a histogram. Okay, again, I'm going to turn both of these other ones off, but you see, well, I'll keep the dot plot up there. You can see how each of these is at a 1, and then we have our 2 here. So you can see the dot plot also over here, or the histogram, sorry. Okay, so that's for what we did yesterday with the mean absolute deviation. So I'm going to go in and undo these. I'll leave that up there for a minute. Okay, so today we're going to look at standard deviation. And standard deviation is a measure of variability, okay, along with the other things that we've learned. You've learned mean, median, and mode. And so to remind you, mean is your average. Okay, sorry, my thing came unplugged. Okay, so the mean, remember, is the average. And for the average, you take the sum of all the data and you divide by the number of data. Okay, now your median is the middle number. And if you're doing that by hand, you have to make sure that your numbers are in order from smallest to largest. Okay, you don't have to do that on Desmos, but you need to make sure by hand they're in order. And then the mode is the one that appears the most often. Okay, so the number that appears the most is the mode. There may be more than one mode, but if they all appear the same amount of time, like a uniform data, there is no mode. Okay, and then going into your variability, we've learned range. which is the maximum minus the minimum. Your interquartile range, that goes with the middle 50% on that box. Your quartile 3 minus your quartile 1. So it's just like the range, the maximum minus the minimum, but it's the inside data, the inner data. And then your mean absolute deviation, which we just talked about, is the average distance from the mean. Okay. Now, standard deviation, by definition, is a measure of the amount of variation of a set of data values. Okay, so it measures that variation in the data. So you can see here that when you have a low standard deviation, like this is 0.7, that means that the values tend to be close to the mean of the data. So if you look at this, the mean of the data is 6.2. It's halfway between these two. Okay, all of these values are within a small amount of numbers from that value. So think of your range. If you do the 7 minus 5, you get a range of 2. That's a very small range, so your standard deviation should also be a very small amount. And over here, a high standard deviation means that the values are spread out. Okay, so here we have a 7.5, which would be in between these two numbers. And our values are bigger anyway, the number values, so our mean is bigger. But also because the range is over 7 values instead of just 2, we have a higher standard deviation. They're spread out more across the grid. Okay, we're going to look at doing these by hand for our basic calculator first, and then we're going to go into using the Desmos calculator for it. Okay, so these are 10, 11th grade girls and how many hours they spend on the phone talking each week. Okay, so they plotted the data, and on my next page you'll see the plot, and we have our chart. Now on this chart it breaks down the standard deviation. Okay, your standard deviation is the square root of the sum of the differences, so the data minus the mean squared, divided by how many data you have. So down here, that n equals, not x equals, n equals 1 to n. Actually, they usually use an I, sorry. So each individual data, I equals 1 to value of n, so however many numbers you have. So each data point, we're going to write that down first. 8, we have a 9, 10, 10, 11, 11. We had 3 12s and a 14. Okay. Now, if we go onto our calculator and we take the sum, 2 10s, 11 twice, 12 3 times, and a 14, we get 109. So that's our total, our sum. And then if we divide that, sorry, I don't know why that went away. We divide that by 10, that gives us a sum of 10.9. So the mean is 10.9. Okay, now each of these numbers is going to be subtracted from that mean, okay, or by the mean. So if we subtract 8 by the 10.9, you get negative 2.9. Okay, then from 9, that's negative 1.9. 10 is negative 0.9, and we do that twice. 11 is 0.1. 12 is 1.1. And 14 is 3.1. Now, at the top of your thing, it says that you need to square the distances. So we're going to go through and square these. Now, I don't remember all of them, so I'm going to come over here and do some of them. Remember, a negative times a negative is a positive, so I'm just going to ignore the negative when I type it in and just put 2.9 squared. That gives me an 8.41. 1.9 squared gives me a, no, hold on, something went wrong there. 1.9 squared, there we go, 3.61. Okay, now 0.9 squared, or negative or positive, is 0.81. I know that one. 0.1 squared is 0.01. 1.1 squared is 1.21. And the last one down here, can't see, is 3.1. Again, I'm going to need the calculator for that one. That's 9.61. Now, for the rest of the data, you'll see here, we got to add those together and then divide by how many data we have, and then we're going to take the square root. So you're taking the sum of those distances, sum of the squares, and you're going to divide it by the number of values, or the number of data. Okay, so we have, if you add this up together, you get 26.9. You're going to divide that by the 10 values that you had, and you're going to take the square root. Okay, so 26.9 divided by 10 is 2.69. Now take the square root of that, and you get 1.64. So that's your standard deviation. So that's a small number, not real big. So that tells us that we have a small spread for our data. Now this symbol here, it's a lowercase sigma. This is the uppercase sigma, that big E looking thing. This is lowercase, and it stands for standard deviation. It's the notation for that. Okay, so we have a spread of 1.64 and a mean of 10.9. Okay, so let's look at the boys' data. Now, on the boys' data, I'm going to go to the next page. We're going to put that into Desmos. Okay, so in my Desmos here, I'm going to delete all the numbers I have in there. And I'm going to put in the numbers on my data plot. Now remember, each dot represents the data, so there's 2 dots, there's 2 of that number. Okay, so I've got my 10 elements here. Now, what I'm going to do is, again, go down to your functions on the keyboard, scroll to the statistics, and I want standard deviation of the population, so the one with the P on it, okay? Because, well, I need to find the mean first, sorry. The mean is 4.3, and then the next line, I'm going to go in and I'm going to find the standard deviation. Okay, now it's got to be the one with the P because it's population, which is the entire set of data. The other one will give us something different, so we don't want to use that one yet. You'll get that later. Standard deviation of the population, so we're going to put that in there. And again, put our letter for our set. So that's 3.769, so we're going to round that to 3.77. Okay, so our mean, let's just, X bar is 4.3, and our standard deviation was 3.77. Okay, so here's the numbers again. Again, you're looking at the functions, and you want to make sure that you go to the one that says standard deviation with the P on it. Okay, that's for the population. Now, our questions are, who had the greater mean? Well, that was the girls. The girls had the larger mean because they talked more on the phone. Okay, now the standard deviation is greater on the boys because the time varies more on the boy data. Okay. So the time for the boys varies more on the hours that they talk. It goes from 0 to 11, where this is just from 8 to 14. Okay, so you have that assignment sheet to do using your Desmos to find your mean, your median, and your standard deviation. Okay.